Ready?
Yeah.
So, trace in space how we move. Where did it move?
We literally move along the line.
Yes, it's just along the line kind of thing, like this. Yeah? What's the rate at which I travel? I know there's no
The
units.
same way time increases.
What's the rate? 1
Per one.
unit per mile, whatever that might be, right? Okay. I think you'll agree then that the distance is 10. Could I get super fancy and say, well, I know that distance, in Calc 1 we said distance is the integral of the speed, yay?
Yeah.
Could we do it that way? What is the speed?
Constant.
Constant. What is the speed? 1. Absolute value of 1 is 1, and therefore it is t from 0 to 10. So we get something like a distance of 10. Obviously, that would be way overthinking it, but you could do that. You with me? Okay. Now then, if I graphed x against time, if I were to graph x against time, then x depends on time, and the graph would be just a basic straight up line. Yeah? Now, although that's a fine, accurate graph of where it is horizontally, as it relates to time, is that graph the path?
No.
That's not the actual path it traveled, you agree? Because that's a two-dimensional graph, and we know it traveled in a one-dimensional kind of way, okay? So you need to write to yourself then that the graph is, and therefore the arc length, is not the path and the distance. Okay. If I found the arc length of this, what's the arc length of this?
10 root 2.
10 root 2. It's 10 root 2, and that's definitely not how far it travels. So finding the arc length of the xt graph is not finding the kind of distance you travel to the path you travel, all right? Now, if you consider planar movement or parametric equation movements here, things are a little different. If I said the position of a particle is given by x is equal to the time and y is equal to the time, if I asked you to draw a picture of the path that this thing traveled, the particle traveled, do that, please. Okay, so would you agree that if I have x and y, then I have two dimensions of position to consider? I need two axes. I need a horizontal and a vertical position to show. And if I were to say that at time, if x and y are exactly equal to time, then surely this would be the starting point. And every second that passed, the x and the y would increase by exactly 1 unit, and so you would end here, yeah?
Yeah.
That shows the path. This shows the direction of movement. I guess I could have shown direction of movement on the first one. But here, what's the distance traveled? 10 root 2. Now, in this case, is this also the same as the arc length?
Yes.
Yes. Now, in this case, then distance and arc length are the same. How do I find arc length? In parametric.
Integral of the 1 and the slope.
1 plus, or is it
Plus.
dx dt squared plus dy dt squared?
The xct plus dy.
Okay. What does that root 2 represent?
The changing y angle.
Change in y index. In other words, I don't care about how fast you did horizontally. I don't care how fast you did vertically. I care how fast. What do you call that when you say, I don't care about the direction, I care about how fast? What?
Speed.
Speed. That's speed. You're still integrating speed. In all, Calc 1, Calc 2, and Calc 3, distance is found by integrating speed. How fast do you go times little increments of time? Distance in one dimension is integrating speed. Distance in two dimensions is integrating speed. This root 2 represents the speed that you are traveling times little amounts of time from 0 to 10. And if we did three-dimensional movement, then it would be plus a z squared, or z prime squared. All right, but in parametric, the graph and the arc length are the same. All right, that's one fine point I want to talk about, arc length. The next fine point is, this is an idea of Calc 2 that Saxon, as you know, kind of puts things in wacky order here. Technically, you should have done what's called improper integrals before this lesson, but we'll touch on it now and we'll hit it hard later in set 127 or something, not 7, that's not it. At any rate, it's this. Say I asked you to find the arc length of this function on -8 to 8. Is that the integral of 1 plus f prime squared, or is that the integral of dx dt plus dy dt b squared? Which of the two arc lengths are we talking about now for this first one? 1 plus. Okay, so we would do 1 plus f prime squared, and f prime, I think you'll agree, is 2/3 x to the -1/3 all squared from -8 to 8. Now, that's a bit of a problem. Why?
Because of domain.
Yeah, domain restriction. It is undefined at 0. Yeah, this is undefined at 0. That's a bit of a problem. Now, if you have an integral that is undefined at 0 or not continuous over the domain, that's called an improper integral. Sometimes you get an infinite. Now, if you are to do this, the calculators now are so advanced that I don't know if your calculator would have a problem with this or not. Why don't you get your calculator out and see if it gives you an error message or not. It might say, I know what to do and do it anyway. I'm not sure technically, but I can tell you what will have to be done to do this well in math terms. This calculator is good. Does it give you an answer or does it give you an error? Error. Okay, so cool. That's good. As it should, because it shouldn't just mindlessly crank out calculations. So, where is the problem area again? 0. Okay. So, if I had a problem, say I was going from -8 to 8, and the curve looked like this, but I have a problem there, then what do you reckon a workaround is?
Take it out.
Okay, take out 0. Instead, we could say from -8 to what? Not to 0. -0.001, yeah? Of that, plus another integral from, that's the left side,
Positive.
from positive 0.001 to positive 8. If you knew it was even or odd, or if you wanted to get into proving even or odd, then maybe you could use a doubling. Is this even or odd? I would probably choose the lazy route and just do this myself, quite frankly. But what do you reckon the proper calculus way is to do this? Now, this is not, this will get you by for today, so this is good. But in terms of laying the foundation for later, what do you really want to know?
Limit with.
The limit, yeah, you actually would say something like, the correct way to do this, though we will do this later, is to say, as some arbitrary number approaches 0 from
The left.
and you're saying of the integral from -8 to a of 1 plus f prime squared. And then you'd also have to add to that right-hand approach. So let's call it the limit as b approaches 0 from above
Other side.
the other side. What is the other side limits?
Positive.
from b to 8. Yeah, that's the way you deal with an improper integral, which we'll cover later, but for now. The point is, if you get an error in doing an arc length calculation, it's probably because it's undefined over the domain of the integral, and you need to figure out, all right, where's the discontinuity, and get close to it. With me? Okay. The same would go true for this. This is pretty much the same idea. So I think we'll just, all right, now, that should be the end of 114. Now, go to 115. 115 is a humdinger. 115 we'll probably have to do over in 3 days because that's a humdinger. That says it all, doesn't it? All right. Now, today's part is it's a technique that you'll need to do the actual concept tomorrow. So let's go to partial fractions. Does that mean anything to you? Did this Ken teach you anything about partial fractions?
Yes.
You guys have done partial fraction decomposition? Excellent. Today we'll go very quick, and tonight's homework will go really, really quick. So, I remind you that, now did you do partial fractions as it applies to calculus or just how to decompose? Okay. Now the reason you learn decomposition is for calculus. It's on its own, it doesn't do much for you, but it is a calculus technique here. Really, she's taught you. Now the problem is this. You have this integrand that's kind of funky, and I could probably try it with trig sub and maybe complete the square. That is a way that would work. I could complete the square and then use trig sub. That is a technique that would go and get you the same answer. But most students would use partial fractions here because it's a heck of a lot easier. The goal is to break up a single fraction, something like this, into 2 separate fractions. Actually, you don't even know what those are. That are a sum and therefore easier to integrate. Now, to do that, you first need to decompose the fraction. Ignore the integral for a second and decompose the fraction. 3 over x plus 2 times x plus 3 must have been the sum of 2 smaller fractions. What were the denominators of those fractions? What do you reckon they were? If they came together to be x plus 2 and x plus 3, then before they must have been x plus 2 and x plus 3. Now the real question is, what were the numerators? And we don't know. Those would have to be pretty perfectly chosen in order to, after adding like terms, to get a 3 in the numerator, right? Is this all familiar?
Yes.
Okay, cool. So how do we go about finding A and B? Let's clear the fractions, yeah? If you mentally multiplied through by what? X plus 2 and x plus 3. If you multiplied through by x plus 2 times x plus 3, it would clear all the fractions. What's the result?
A times x plus 3 plus
3 equals A times x plus 3. I agree. When you multiply that first term by x plus 2, x plus 3, the x plus 2 would go away, and you'd be left with an x plus 3, right? And then B times x plus 2. Cool. Okay? Now, if you're the first time, you probably thought, I know that I'm not supposed to be able to solve an equation with 3 unknowns, right? This is true for all x's. If x is 5, then I should be able to find an A and B that make it true, right? X is anything I want. Well, what is a perfect x that would make my life easier?
0.
Not 0. Let x equal -3. Now, if x is -3, then your life is just made a heck of a lot easier because now the equation becomes 3 equals b times -1, and that tells you that b has to be -3, yeah? Now again, this equation is true for all x's. So what's another x that would be great to choose?
-2.
Yeah, if you let x equal -2, then 3 equals A times 1, which implies A is 3. And so we have decided that, again, I'm showing like I usually do the first time through, I'm going to show a little more work. And I would. We said that 3 over x plus 2 times x plus 3 must have come from 3 over x plus 2, which is what a over x plus 2 is, minus 3 over x plus 3. Now, very few people make mistakes on this, but for the first time through, let's verify that. How can I verify that that's true?
Multiply it out.
Yeah, if I got a common denominator, if I were to check this, then surely the common denominator is x plus 2, x plus 3, and this would be something like 3 times x plus 3 minus 3 times x plus 2. If I distributed and combine my terms, 3x minus 3x would go away. 9 minus 6 is 3. That works. Do you agree? It is equivalent. You with me? All right. Therefore, the whole point of the problem then is that my integral can be rewritten instead of 3 over x plus 2 x plus 3. I can write it as 3 over x plus 2 minus 3 over x plus 3 and integrate with respect to x. Now, I think you'll agree that's a heck of a lot easier to integrate, yeah? Let's see, that's a derivative of the first. 3 natural log of the absolute value of x plus 2 minus 3 natural log of the absolute value of x plus 3 plus c. I don't know what the answers in the back of the book look like, whether they use log rules to clean them up. I personally don't care if you clean it up or not. But in terms of a multiple choice, what was another possible form?
Natural log of x plus 2 to the third.
X plus 2 to the third over x plus 3 to the third. Would you still need the absolute value? Could that be negative? Yeah, you would need the absolute value in that case. Let's see. You could put it all to the third. There's a lot of possibilities. But again, I don't care if you simplify it or not as long as you integrate. Does that make sense? Okay. Try those on your own then, please. Verify you get the gist. Or with your method Vigos. What's the first thing you should do with the first one, people? Factor it. Factor it, yeah. How's the first one going? Are you getting 2 natural log of the absolute value of x plus 4? Plus natural log of the absolute value of x minus 2. Okay, cool. Sounds like you're doing well. The second one seems like I'm just getting wacky. That's actually the problem you'll have to be able to do tomorrow. So it's really important, the second one. Yeah. Oh. How's it going?
What?
What's one thing you let p equal?
0 and L.
0 and L. Sounds good. Did you get A and B are both 1 over L?
Yeah.
Okay. All right. So let's make sure that you didn't make a common sign error here. Did you get, first of all, the partial fraction decomposition is 1 over L over P and 1 over L minus P.
Yeah.
Okay, what is the antiderivative of 1 over L over P?
Natural log.
Natural log of absolute value of P over L, or 1 over L, natural log of absolute value of P, yeah? The second one, you best be careful. What is it? 1 over L log or negative 1 over L log? That's either U sub or think U sub. What's U?
Negative P.
Yeah, U is L minus P and du is negative dP. This is not plus, it's minus. Screaming U sub at you. Whether you do U sub or think U sub, it's 1 over L, it's minus 1 over L natural log of absolute value of L minus P. And if you fail to use that negative, you are going to have a great hard time tomorrow. Understood? Okay, cool. And the last one, it asks for partial fraction decomposition, but any time, we talked about this a little in the first semester, but it's not in the book. Anytime you get an integrand where the power at the top is as big or bigger than the numerator, you have to divide first. You must divide first. So the first thing you have to do before you decompose is divide. X squared plus x minus 12 into x cubed plus no x squared plus 3x minus 2. Right? How many times does x squared go in x cubed? X times. Multiply, you get x cubed plus x squared minus 12x. Change signs. Draw the line. And you should gradually be working your way right in the dividend. So x cubed subtract away, you get negative x squared plus 15x. Bring down the minus 2. Are you with me? Okay. Now you do the same thing again. How many times does x squared go into negative x squared?
4.
One time or negative one time? Negative one time. You do have to continue on. It's not like we're finding a slant asymptote. You have to find the remainder now. So now we are going to multiply. I get negative x squared minus x plus 12. But I'm subtracting that, so I change signs. Draw the line. Negative x squared plus x squared goes away. 15x plus x is 16x minus 14. You can see where I'm coming from. Okay, now the problem equivalent is x minus 1 plus 16x minus 14 over x. I'm going to factor that in preparation for partial fraction decomposition. Okay, an equivalent algebraic expression is x minus 1 over 16x minus 14x plus 4x minus 3. Are you with me? Okay, now surely the left part is, that's easy to integrate. This is the part now you're going to have to do partial fractions. So now it's partial fraction time on that part. You get 34/7 and 78/7 for coefficients? No? Yes? Okay. All right. So, simplified for integration. We're going to integrate, don't forget your x minus 1. And then your partial fraction decompositions. 78/7 goes over which one? X plus 4, right? And 34/7 goes over x minus 3. We? All right. Integration time. What's the integral? 1/2 x squared over 2. Yeah? Minus x plus 78/7 log of the absolute value of x plus 4 and 34/7 log of the absolute value of x minus 3. All right, that's pretty gross. That's probably, for now, as gross as you'll get. We'll do more partial fractions. There's actually 3 different partial fractions. That should do it. So you can see the homework is just a lot of partial fraction problems. You have to be very solid on these to succeed tomorrow. The back is meant to be review of exponential growth, which also relates to tomorrow's lesson. So, the homework should be easy. I think you should, if you're good at this, you should be able to crank it out in probably half the time a problem set takes. Alrighty, questions on last night's homework, 114. How rusty were you?
Number 9.
Oh goodness, 8? Is 8 the replacement? 9, 4, 20?
The one below 8.
The one below 8?
Number
I don't need
before
4. I don't need 9. I was just saying.
Oh, 9 is the one below 8.
Do number 9. Yeah.
Oh, and also 9.
Yeah, I do number 9.
Okay, I don't know what's going on, but okay. Let's go. Left it. Sorry, I'm all over the place. Sorry, just a second. All right, sorry. Okay, lo siento, mijos. Got that one. All right. Okay, so you didn't say 4, you said 8. So 8, here we go. Sorry about that. Okay. So, what did your path look like?
It had like a little bump and then it went down.
And then went down? My notebook. All right. I'm freaking out. Man, if I lost my whole notebook, I'm screwed. Darn it. Okay, see, please. I'm showing great faith in you, sir.
I think
Okay.
I dropped it wrong.
You did? Is this what yours looks like?
I don't think I did the bounce right.
No?
Yeah.
Okay, cool. And it starts at 0, 0? We? Okay, cool. All right, at what time does y attain its minimum value? Question, did you try and graph this in your calculator in parametric mode? Okay. Will it let you find a min on the curve in parametric? In parametric mode. It will not, okay? So the calculator is not programmed to do that. So this is part of the skills you're going to have to, one of the skills you're going to have to develop, calculator skills, and that is to switch between parametric and regular function. If you want to find the minimum y, then I would just graph, now you could actually try and do this by hand, but you want the minimum y, yeah? If you did this by, all your calculus knowledge of taking derivatives and finding minimums, that's cool, but you can use a calculator and graph y equals. Now, you actually would put it in function mode and graph just y equals x cosine of x and find the min on 0 to 2 pi. Now obviously it's not going to be the same as parametric, but it gets you the value that is the lowest for that y equation. So did somebody get a minimum y? Oh, at what time? At what time does it hit its minimum y? Anybody? You got it? 3.426? You all agree? I don't have I left my notebook at home, so I don't have my key in front of me. 3.426. And once you know that, then the x and the y at 3.426 can be found just by plugging that time into both x and y equations, yeah? So what is the x at that time? What is the x of this place? Anybody? 3.702? 706?
06.
Okay. And what's the y at that time? Negative 2.223?
Sorry, 288.
288?
Negative 3.288.
Negative 3.288. Do we agree?
That's-
Katai, is that what you got? Negative 3.288? Well, frazzled then because I'm freaking out that I lost a whole semester's worth of material. All right. Write an equation for the line tangent to the curve at time pi. So hopefully you found the x and the y. What'd you get for x? Something like pi?
Yes.
And y is negative pi?
Yes.
Okay. How do we find the slope? dy dt over dx dt, yeah? Now you could do that by hand or by calculator. Does anybody have that calculation for me? Negative. Negative seems right. Negative 1/2?
Yeah.
Oh, that's good. Okay, so something like y minus negative pi, so y plus pi is negative 1/2 x minus pi. Okay, cool. Distance traveled. Is distance traveled by the particle the same as arc length?
No.
In parametric, is it?
It is.
Yes. Okay, so distance in parametric, when you find the length of the curve, then you're finding the length of the path, and therefore you're finding the distance traveled on the path. So the distance is the arc length. Over the interval, I assume they're talking about the interval from 0 to 2 pi of x prime or dx dt squared and dy dt squared. If you found the derivatives by hand, cool. If you had the calculator calculate them, that's okay too. They weren't too bad really. But what'd you get for an answer? What'd you get for the distance of that? 16.452 seems reasonable. Obviously it traveled 8 units horizontally, but it was curving, so it's much more than 8 units, so that seems like a reasonable answer. You with me? How'd that go? Okay. 9. This one, it doesn't seem like it would clean up, but it really does. It cleans up a lot. This book was, I pulled this from his, it's got some gross ones. All right, so how do you find total distance in parametric? It's the arc length calculation, yeah? All right, so what is x prime? This is a really long problem. A times negative sine t plus
That is no certain.
plus t cosine t plus sine t, all squared plus
A
A
cosine
cosine
T
T
plus T sine
plus T
T
sine T
minus cosine T.
minus cosine T all squared. Okay, so a little bit of clean up. Okay, so this is surely A. Inside there, the sine squared, the signs drop out, and I just have T cosine of T. So I have AT cosine of T all squared, right? Do you agree? Okay, the other one, the cosines drop out, and you have AT sine T all squared. Alrighty, now we're getting there. So, isn't this something like A squared, T squared for both? And I could factor out A squared, T squared for both, leaving me with cosine squared plus sine squared when I take out the common factor, yay? Well, that's one by identity, and the square root of A squared, T squared is just AT, so really at the end of the day, we're just integrating AT with respect to T, and that is
Squared over 2.
AT squared over 2 from 0 to pi, so we get something like A over 2 times pi squared minus 0 over A over 2 pi squared.
So it's C.
What? C? Yeah, that's it. Yeah, I was looking at D, but A is squared there. So it's C. Okay? Okay, that's okay. Okie dokie. 9. 9. Is 9 still a question? All right. You can scratch find area too. We never covered how to find area in polar yet.
Scratch what?
Okay. 9, 14. Okie dokie. Okay, so we're approximating. Let's. Let's just blow off the 10 decimal places and instead, what was I saying we should do on Newton's method problem? Did I say?
On the problem, you said you two iterations.
2 iterations. Okay, we'll do 2 iterations. Depending on what you chose as your initial, your answer could be very different. But wouldn't you agree I'm trying to solve the equation x squared equals sine of x? Does Newton's method find intersection points or does it find zeros? Zeros. So how do I make it a zero problem? All right, let's let f equal x squared minus sine of x, and I want to find the zeros, yeah? I don't even, so here's sine, here's x squared, here's sine. So I assume they're asking us to find, that's the first quadrant point. So, what did you guess, 1 maybe? Is that cool? It says, oh, I told you to start with 1? Oh, well, there you go. Okay. All right, so if I let x initial equal 1, then what's the formula for the first iteration? What's Newton's method formula? X naught minus f of x naught over x naught, okay? If you do that at an x naught of 1, then it's 1 minus f at 1 over f prime at 1. Is somebody that used an initial of 1, tell me what your first iteration was? 0.891, thank you. And x2 then is x1 minus f at x1 over f prime at x1. And if you give me that one? 0.877, thank you. Okay, and I think I said 2 iterations, so that's what I would. Very cool. Okay. 20, is 20 still a question? Yes, okay. 20. not changed, is it? I don't have the colon. Is this it? Okay. This is trig sub. So what did you let your x equal? Secant, and the 4 you played with by making it a 2 secant of theta, yeah? All right, so we're going to let x equal 2 secant theta. Therefore, dx is 2 secant theta tangent theta. And the integral becomes theta. In the numerator, 2 secant theta tangent theta d theta. And in the denominator, 4 secant squared theta minus 4. Do we agree with that trig sum? All right, let's do some cleanup. The numerator, I can pull a 2 out, and secant theta tangent theta is cool. How does the denominator clean up?
That's tangents cross out.
All right, so I can pull out a 2, and it's eventually secant squared minus 1, which is tangent squared, which is square rooted is tangent, so the tangents drop out, and you're just integrating secant, yeah? What's the antiderivative of secant? Natural log of secant plus tangent. And now we have to sub back, yeah? So, if x over 2 equals secant of theta, then theta is an angle. X is what? What's the ratio of sides for secant? Hypotenuse to adjacent. So hypotenuse is x, adjacent is 2. Means that opposite is the square root of x squared minus 4. Now we're ready to sub in for anything. Secant, you don't really have to look at your triangle. You can see secant is x over 2. But the tangent, the triangle helps to get tangent. Tangent is
Square root of x squared minus.
And then as far as telling if your answer is fine, I don't know if he does log rules and plays with it and all that stuff. But that is part of the skill to decide, is my answer the same? Practice that because that's going to help you choose the multiple choices, right? If you're not sure if your answer is the same, ask me, but I think we're good. Any other questions on 114? Cool. But they're square rooted.
I was thinking.
Okay, so the good question is they have, so, shoot. If you look at this as this minus log of 2, you agree that divided by could be log of 2? Are you with me?
So you just
This is
copy
a
it
constant.
as
If you roll it in with the C,
right in
it's
your
like a big
zone.
loop. That's what it is.
So I don't know what book I gave you, but I apologize. So you were just looking at me like Micaiah thought no expectations. I had a very
All right,
strong
have a great
like
day.
ADD moment where I was like, idea gone. I was like, so apparently when it's gone, face it. You were listening like offended or something, and then after that, I was like, oh my gosh, your face.
I like the light whiteboard.
I don't even know as much as I study so.
How was your first day of counseling?
I think it is already on your
Honestly, this is just really like,
Okay, yeah.
I've got a lot of shit. The internship is about 4 or 5. One or 2 people doing online classes. Yeah, a lot of just running passes.
It was not to pretend social accomplishment.
All right. Have a great day. Thank you.
Thank you, Mr. Fernandez.
You too, Brennan.